Hello everyone, I am Professor Amit Vyas, Computer IT Department from Dr. Subhash Technical Campus. Previous lecture, we had discussed about what is the analog data and analog signal. Today, we are discuss about analog data and digital signal. So, we can show the what is the modulation techniques and what are the parameters are affected in the modulation. You can show the what is the amplitude, frequency and phase and the different encoding techniques. So we can also be discuss the analog data and analog signal. We can discuss what is the modulation and what is the use, and also we discuss the types of modulation. We can discuss the amplitude modulation and angle modulation. In angle we can discuss the what is the frequency modulation and phase modulation. Now today we are discuss analog data and digital signal. In this process can be termed as a digitalization, which is done by the pulse code modulation. It is nothing but a digital modulation. The sampling and quantization as an importance factor. So the delta modulation given the better output than the PCM. We can show the pulse code modulation and delta code modulation because of sampling and quantization is the importance factor in the modulation. So we can show the pulse code and delta modulation. So what is the pulse code modulation? A signal is a pulse code modulate to convert is the analog information into the binary sequence such that using OS or any operating system. So what is the signal? Signal can be modulate and convert the analog data into the binary form, and binary form to can display the pulse code modulation, and this is the information is converted using analog information to the binary sequence using pulse code modulation. The output of the PCM will resemble a binary sequence. So this is the pulse code modulation. The modulate is convert the analog information into the binary sequence, into the binary form. The following figure you can show that this is the figure. This is one signal and this is the PCM output for your signal. So the following figure is show the example of the PCM output with respect the instance the value of given the sine wave. You can observe that this is one sine wave and this is one convert signal for the analog information into the PCM output. Instance the pulse train is PCM is produced the serial number of digits, hence it is called the digital. You can observe that here. This is one input of the sine wave for the analog signal for the using data also, and this is the output of the PCM. So this is the convert of the PCM out. Each of these digits through the binary code, it represents the approximate amplitude of the signal sampled at an instance. In the pulse code modulation, the message signal is represent the sequence of the code pulse. So what is the sine wave? So this is the sine wave and this is the one PCM output. It is the produce the approximate amplitude signal for the instance. You can show that here. This is one signal and you can produce the output. PCM, the message signal, is represent the sequence of coded pulse. This message signal is achieved by the representing the signal in the discrete from the both the time and amplitude. So this signal is also be used the timeline and sequential of the data. The sampling rate. So this is one basic introduction of the PCM. You can show that pulse code modulation. Here we can show the sampling rate. So this is one basic. You can use the what is the sampling. Now we are discuss the sampling rate of the signal should be higher than the Nyquist rate to achieve the better sampling. The sampling interval is a differentiate the PCM is reduce the consistency by the sample to sample amplitude to the difference is very small, as if the difference in the 1 bit quantization. Then the step size is very small. The sampling rate is smaller than Nyquist rate. So because of different PCM is reduced some consistency and sample to sample is given some amplitude, we can differentiate. So 1 bit quantization is the step size is very small and it is denoted some delta. So second part is a delta modulation. So what is the delta modulation? The types of modulation where the sampling rate is a much higher and in which the step size after quantization is smaller than delta, such the modulation in terms of delta modulation. So what is the delta modulation? Where the sampling rate is higher and step size is quantization is small. So the sampling rate is high and step size is small, then it is called the delta modulation. So we can show what is the use of the delta modulation or features of delta modulation. Our sample input is taken to make full use of the signal correction. The quantization design is simple. The input sequence must be higher than Nyquist rate. The quality of modulate, the design of modulator and demodulator is a simple. So this is the delta modulation features. High Nyquist rate, modulate the quality, design the modulator and demodulator, and it is the simple. So this is the features of delta modulation. You can also be shown staircase is approximate the output waveform. The step size is very small. The bit rate can be decided by the user and it requires the simpler implementation. So this is one features also. Also we can use the delta modulate is a simplify the DPCM techniques. Also view is a 1 bit DPCM scheme. As a sampling interval, it is reduced by the signal correction, it must be higher. So this is the one features of delta modulation. So what is the delta modulation and what is the pulse modulation? You can show that here. The pulse modulation, it is modulate is convert the analog information into a binary sequence and represent by the PCM. You can show that. So this is the PCM. It is convert the analog signal into the PCM mode for the binary number, binary sequence and correct your data. So this is the PCM. So this is the importance. And what is the delta modulation? The sampling rate of the signal is higher than Nyquist rate and to be achieve the sampling. So how can you achieve the sampling? The Nyquist rate is higher, so you can achieve the sampling. So what is the delta modulation? Where the sampling rate is higher, which is the step size is after quantization is smaller than delta. So this is the delta modulation and this is one features of the delta modulation. So we can show in delta modulation. The delta modulation is compromise the 1 bit quantize and delay circuit along with the 2 summer circuit. Following the block diagram is delta modulation. We can show that 1 bit quantizer. This is the one sampling input is omega, and this is the output. This is the accumulator. It is not compulsory. You can write what is the delta modulation in explain in details, but you can write only for the delta modulation and features of delta modulation, and what is the advantage of the delta modulation. This is the one extra information you can here we can write that staircase approximate waveform will be output of the delta modulator with the step size is a delta. The output is quality of the waveform is modulated. So this is the staircase of the output. This is the your input and this is the output. So output is also dependent for the delay. If the delay is occupied, then you, this is the add in the input for the next delta modulation. Then delta demodulator. The delta demodulate is compares of the low pass filter, a summer and delay circuit. The predictor circuit is eliminated here, and here no assume as the input is given the demodulator. So this is the one omega and delta circuit. So here we can no assume, no await 1 bit you can add that in the delta modulation, but only compares the low pass filter, summers and delay. So you can add delay also. So low pass filter is used for the many reasons, but the one is noise eliminator for the out of band signal. The step size error that may be occurrence is transmitted, it called the granular noise, which is eliminated here. You can show that here the inputs and outputs, and finally low pass filter is a demodulate output, but here if the delay is occupied, then you can add the delay. If here no noise is present, the modulator output is equal to the modulator input. So this is the input is occupied demodulator, and this is the low pass filter, but it is any noise is occupied, then output is not. So if your delay is occupied, then you can add the delay in the next signal or next data information. Also delay you can add in the low pass filter. So this is the delta modulation and demodulation. So what is the advantages of DM over the DPCM? The bit quantization, then second, very easy to design for the modulator and demodulator. However, the existing some noise in DM means the delta modulation, and is following two types of noise. First is a slope over the load distortion, is a delta is small, and granular noise for the delta is large. So this is the delta modulation and demodulation. So you can show this is the complete for the analog data modulation. You can show analog and digital signal in the previously. Today we are discuss analog data and digital signal. So one topic is completed here, the topic of modulation, and the modulation is the amplitude, frequency, phase, and all the frequency modulation here completed. And the second is digital to data and analog signal, one part is completed. Analog to analog signals is completed. We can also be discuss the analog data and analog signal in the amplitude modulation and angle modulation. We can discuss the frequency and phase. And today topic is analog to data and digital signals. The topic of pulse code modulation and delta modulation is completed. So this is one basic modulation in the chapters is complete for the analog and digital data. So this is the sampling and importance factors of the modulation and demodulation is completed. Also, in the analog and digital data, we can show the what is the sampling rate and n-cube rate. So here the delta modulation is importance for the features is importance, and one delta definition. What is the delta modulation? It is the use for the low pass ensemble, low pass filter. So this is the importance. So this is the complete of the modulation. Thank you all of you.